Hey you. Yeah, sorry about that. That took a little longer than I wanted, but yeah. Okay, thank you. You're such a sweetheart. Thank you. Okay, all right. Sorry. Okay, so we stated the properties, and as I said, like when you go in one direction, it's expanding. When you go in the other direction, it's condensing, and and there are places where you got to put them all together, right? So, um, it goes without saying, and I didn't see anything like this on your worksheet, but let's say you have like log base a of like x to the second power, but notice I have a parenthesis over everything. This is not equal to 2 log base a of x. This is a wrong application of the power property, so you have to be careful of like where the power is. So this 2 has to only be like, in order for you to use the property, it has to only be on the input of log. So if it's like that, then yes, this is equal to 2 log base a of x. Now, so a good example here is like, like and the chart, obviously also, like it goes without saying, but in order for you to use these properties, the log base has to be the same. For example, in the chart, it's in the first box, it says log base 2 of 7 and log base 2 of 4. And so you condense by multiplying 7 and 4, because product is to sum, and so sum is to product. And so you just went back and the product rule, and so you condense, so to speak. Now, but the point that I'm trying to make is both of them have a base 2, and that's why you were able to do that. You probably know that already. But what I'd like you to pay attention to is the third box, right? So it says log base 2 of, I want to make clear like what I was talking about, like a wrong application of the power rule. Log base 2 of 2x, it says. So again, this is technically supposed to be an absolute value, but it's okay. So it's, I do that too, and sometimes it's written without the absolute values. Now, the second one is log base 4 of 4x squared. Now, if we were, let's say, I know this is not the task, but if we were to expand, right? This is one thing you could do. You could write log base 2 of 2 plus log base 2 of x, um, and then plus log base 4 of 4, and then plus log base 4 of x squared. And then now I could put from the x squared, I can put the exponent 2 in front. But notice that since it's not in parentheses, the exponent, this 2 there as an exponent, it's not on 4. It's only on x. That's why I would only write it in front of the part that I have, where I have an x, log base 4 of x to be specific. So that's if we're expanding. And it should be very obvious that what I did to go from here to here is I repeatedly applied the product rule. Okay, all right, so the other thing, and if we go to the next box, right, like the next set of boxes, I should say, you have like log 6. Again, from my very first question, like log without a base is base 10, and you should know that. Now, since it says expand, what it's asking you is to break up 6 into a product, because that's the only way you can expand it. So you go log 2 times 3, that's 6. And so that's equal to log of 2, log base 10 of 2 by that I mean, plus log of 3, and that's all there is. And that's what you have. Actually, you showed the base is 10 also, and that's well and good. So with or without the base, that's, and so box 5 and box 6 are very much the same. And so talk to me about what you did in 7. So I'll write it. It says log base 3 of 24 minus log base 3 of 8. So talk to me here. Yeah, and how did you know to divide them? Exactly, exactly. So, why are you talking all soft today? Are you tired? Okay, yeah, I'm sorry. Me too. Like, I don't know what it is. Something in the air. Sorry, go ahead. That's funny. Um, yeah. So, after you divide, it's like log base 3 of 3, and that's 1. And so we're done. Okay, got it. Um, okay, so, um, the next one. Oh, yeah, like, in the next one, right, you wrote log base 2 of 15 minus log base 2 of 15, and you turn that into log base 2 of 15 over 15, which is log base 2 of 1, which is 0. So I'm sure you already know this, but log any base, it doesn't matter what the base. If the input is 1, log any base a of 1 is always 0. Because what you're asking is a to the what power is equal to 1, and obviously that's 0. Okay, just to mention that in passing by. 9 is like very straightforward. Log base 4 of x to the ninth. If we go over the hour mark, anything over the hour mark is on me. So log base 4 of x to the 9 over x squared. So that's log base 4 of x to the 7th. And so yeah, you're condensing. And you're just using the quotient rule. Obviously, we simplified. We crossed out exponent to a 9 into a 7. Okay, expand using the quotient property. Love, like you also chime in on I got it, or we can move on, or we should do which, if any, do you feel? I have my eyes on 17 and 18, but other than those two, do you have anything else that you feel we should talk about? Mm-hmm. Mm-hmm. Sorry, why can't you just use what again? Because that would be too cheap. Like, you can't do that. Yeah. It's okay. Yeah, there are a couple of questions that, as I saw, that are to come later, that you cannot do without a calculator. So that's for sure. Now, 17 is like a small note of caution, right? So it says expand using the power property, simplify if possible. So you have 3 log base, or log of 4x to the 4 to the x minus 1. Now, what base is this? Yes, exactly, because it's not written. Like, again, like, you're super bright, I know that, but like logs are like tricky for some kids, like even for smart kids. So it's like I'm always like pleasantly surprised by like your mastery, and so obviously you pay attention in class. Good job. Okay, so it says expand. So you have 3 log. Obviously, we could put the 3 back as an exponent, but it says to expand, so that's not what you're being asked to do, because that would be condensing. So you'd go log 4, again, implicit that it's base 10, and so then we put the x minus 1 in parentheses. So now, your work is correct, because you wrote 3x minus 3, and that's having distributed that 3. But I'm just like making the extra point that, yes, very, very well done, but it's very important that like you put the x minus 1 in parentheses, because it's 2 terms, and therefore you need to multiply both of those terms by 3. So that's that. Now 18 is just a small note on like, it says log base 7 of square root of w. So it's just a small note on like understanding that square root means to what exponent? What's the exponent for square root? Mm-hmm. You got it. It's okay. Oh, no, no. Sorry. Yeah, it's okay. I meant like I was encouraging you. It's okay. I know you know. You're just tired. It's 1/2. So cube root is 1/3. Blah blah blah. So and square root is 1/2, and so on. Okay. Sorry. You can't write all the way up. So cube root of x means x to the 1/3. Square root means x to the 1/2. Blah blah blah. And so now, once you've gotten the square root in terms of like 1/2 exponent, then you can put the 1/2 and be like 1/2 log base 7 of W. Done. Make sense? Okay, cool. All right, so let's keep it moving. Next page. Yeah, right. Like, so the first one is pretty straightforward. It's quotient and power, right? Like, as you wrote. So it's like log base 6. There were a couple of questions that 2 log base 6 that were done incorrectly. So I want to look at those, but I'm sure we'll cross that bridge soon. So again, it's base 10. Sorry. So first, put the 2 as an exponent. So that's going to say log base 6 squared minus, log base 10 of 6 squared. So it's log of 9. And so now that's, we just got done applying the power rule. So now you have to do the quotient rule. So that's going to say log of 36 over 9. And that's log of 4. And, you know, since we said it's base 10, like this is log base 10 of 4. But then, you know, we don't know how to do that without a calculator. So you have to leave your answer as simply as log of 4. Because we don't know what 10 to what power is going to get us to 4. Okay, so 20, I think you're good. So chime in again, love, like if you feel we need to go over any of these. But yeah, I think 20 is good. What do you think? Sorry. Okay, and then 20, 21. Yeah, so 21, I that's one of the ones that I felt was done incorrectly. Not I felt, I know. So talk to me about 21 because, look, it says 7 log 4 of u minus 3 log 4 of v squared. So talk to me about how you'd go about this, dear. Exactly. So very, very good job. Like the first thing you should do is take care of the powers because, yeah, they're like in front and it's easy to take care of. Okay, minus, yb to the 6. Nuh-uh, you did it correctly. It is to the 6, but I was asking why. It's okay. It's okay. It would be a back-to-back exponent rule, and that's the multiply. Because look, I'll write it. It would be v squared to the 3rd, and so then in this case we'd multiply. So you are right to say to the 6th. So log base 4 of u to the 7th minus log base 4 of v to the 6th, and finally we do what? Exactly. That's the step that was done incorrectly. It's okay. But u to the 7th here, we divide, not multiply, as you just said. Excellent. So this would be the final answer. Good. All right. So 22, I think we're good. Oh, yeah. Well, yeah. So I'll just very quick note on 22. So log base 2 of 15 plus log base 2 of 4 minus log base 2 of 6. So take care and do it in order, right? Like there's a product rule to be applied here because, well, it's a sum. Sum to product, product to sum. That's what we said. So that'd be log base 2 of 15 times 4, that's 60. And then you still have the trailing minus log base 2 of 6. And then now do the divide rule. So log base 2 of 60 over 6. So that's log base 2 of 10. And because 10 is not a power of 2, we can't like simplify more than that. That's your final answer. Okay. Sorry. And 23, I won't write, like, it's done correctly, but I want to ask you, why is it, first of all, isn't it a plus in front of the 1/2, so why did it turn into divide? It's okay. It's sorry. It's okay. Um, yeah, no worries. All right. So, if it's, I think, yeah. The well, looking at your final answer, did you do you think it was done as a divide or as a plus? Yeah, exactly. Sorry, go ahead. Yeah. So if you did it, your final answer is done based on it being a plus instead of a divide. So I want to point that out. Also, my other question is, how did the 49 turn into a 7? Yeah, exactly. I was asking a rhetorical question. It'd be log base 3 of 49. The 1/2 would become an exponent on 49. But that'd mean that you have log base 3 of square root of 49. And so that's log base 3 of 7. Fair? Okay, cool. Um, now, uh, having seen that, I don't think we need to go over the next one. Yeah. Yeah, like obviously on the next one, you put the 2 on 6. I'm looking at 26. You put the 2 on 6, and then you put the quarter on 16, which means the fourth root. That's why the 16 turned into a 2. And there's a minus sign between them, so you divide it to turn it into an 18. So you did that first, and then later applied the product rule because there is a plus at the tail end. And again, do it in the order that it appears. But yeah, it's done correctly. Um, Talk to me about what you did in 27. It's done correctly, but actually, there's one bit that you need to fix, but it's okay. But tell me your first step. What did you do there and what you boxed? Yeah, yeah. Uh, Sorry, go ahead. Yeah, no, it's a product between x, y, and z to the fourth. So you use the product rule, product to sum, product to sum. So you separated them into a sum. But then it's not finished all the way because I suppose, yeah, because like it's only when you're condensing that you want to put the power on the input of log. So what am I talking about? Why is it not finished all the way? There you go, beautiful. All right, great. So 28 is good. 29, it's good. Like like you put the two. So sorry, like 29 is like a curious one. So look up at the board. So you have log base 7 of like q to the 4 and then r to the second and then all that is to the second power. So you said this is log base 7 of q to the 8th, r to the 4th, and then you expand it from here, log base 7 of q to the 8th plus log base 7 of r to the 4th, right? And then you put the 8 in front, 8 log base 7 of q plus 4 log base 7 of r. Now, that's good. An alternate path, right? Just to point this out is you can use the exponent rule twice, which is from here you can put that 2 in front first, right? So if we went that way, you'd have 2 times log base 7 of q to the 4th. But I like the way you went about it, so I'm only mentioning this, as a possibility. Perhaps maybe I shouldn't. That's bad teaching because what you did is perfectly fine. So then you keeping in mind that this 2 is multiplying everything, you put a parenthesis and be like log base 7 of q to the 4. Now I'm applying the product rule. Log base 7 of r to the second, and then 2 times 4 log base 7 of q plus 2 log base 7 of r, and then now distribute the 2 there and there, and you get to the same place. 8 log base 7 of q uh, plus 4 log base 7 of r. Make sense? Okay, good. Um, so in 30, you decided to give the exponent to, yeah, like, okay, so 30 is well, done well. 31 and 32 looks like we need to do together. And you do the talking. So log of square root of, sorry, log of square root of 7x cubed. Talk to me. Mm-hmm. Yeah, exactly. So log 7x to the third to the 1/2, and then yeah, exactly. So that's I think that's the path of least resistance. So it'd be log of 7 to the 1/2 and x to the 3/2. It makes sense? But then we need to continue. How exactly? Keep talking. You well, yeah, you can't do it without a calculator. But big picture, what rule can we apply? What's happening between these two guys? It's okay. Yeah, but they're also being multiplied, so we can use the product rule. So go ahead. Yeah, so you go log base 7, sorry, base 10 of 7 to the 1/2 plus log x to the 3/2, right? And to finish, yes, 1/2 log 7 plus 3/2 log x. Fair? Okay, cool. Uh, Next is, um, yeah, again, I want you to do the heavy lifting, so I want you to do the talking. Log base 3 of the 4th root of m to the 5th and n squared. So talk to me. So you're doing too many steps at once, but it's okay. Go ahead. M to the 5/4 and n to the what? Yes. It's okay. Sorry, it's not your fault. I just like showing more steps. But anyway, go ahead. Then yes, it's a product between this and this. So log base 3 of m to the 5/4 plus log base 3 of n to the 1/2. Then use the power rule. 5/4 log base 3 of m plus 1/2 log base 3 of n. Make sense? Okay, cool. Now, so finally we're done with this. And again, the reason why I like this, why I think you can get 100 on this as long as we don't make careless mistakes, is because, like, it's all straightforward. Like, and also on just two topics really. It's about logs and exponents, which are interrelated anyway. Now, the name of the game with exponents is always make the bases the same. Once you make the bases the same, just set the exponents equal. That's the whole point of how you solve exponential equations. So you have 2 to the power x plus 1 is equal to 2 to the 9. Well, this one is ready made for you, kiddo. Like, the bases are the same. And so you just set the exponents equal. But when the bases aren't the same, the first thing you should do is make the bases the same. Okay, so x plus 1 equals 9. So x equals 9 minus 1, which is 8. Make sense? Yeah. Okay, same thing on b. Like, I just needed that, like, I knew like, the first one, we probably didn't need to go over a, but yeah, anyway. And c, the bases are the same, all right, but you still have to use exponent rules because and on the left side they're not combined. So you have 3 to the k and 3 to the k plus 2 equals 3 to the 5k minus 1. And so here you have to use the additive property. So like we know that when it's written like that, we add the exponents. So you get 3 to the k plus 2 is 2k plus 2. And now it's turned into like the previous question because, well, we have the same bases and just one exponent on both. So there's no more exponent rules to apply. So you just drop the bases and just set the exponents equal, and I know you know how to solve it from there. Fair? Yeah. Okay, cool. And example 2, the solve again, not tricky. 5 to the 3x minus 6 equals 125. Make the bases the same. They're not this. I mean, I'm not yelling. Sorry. I'm like trying to like accentuate or whatever. Like 125 is like 5 to the third. And so now that the bases are the same, set the exponents equal. Name of the game. Make the bases the same. Sorry. I feel like I'm doing an advertisement for bases and exponents. Sorry. 8 to the 2x is equal to, I like the way you like chuckle. It's like adorable. Sorry. So 8 to the 2x and then 4 to the x minus 3. So again, make the bases the same. But talk to me. You do it. Mm-hmm. Go ahead. Exactly. Very important is, again, this is more than one term. So when you multiply the 2 and the x minus 3, you did it correctly. You said it correctly. It needs to be, like, you need to keep in mind that this needs to be in a parenthesis. That way the 2 is distributed, and that's how you told me to write 2x minus 6. Now that the bases are the same, set the exponents equal. So it's 2x minus 6. And so we set this equal to that. And yeah, has anyone told you that you have, like, a very subtle like Italian accent? All right, today is the first time I heard it. Yeah, like it's very subtle. So um, now you have 2 to the x is equal to 7, and the point that is being made here is, well, you can't solve this without a calculator, really, because well, we don't know what power 2 should be raised to get a 7. But as you said, we know that 2 to the second is 4. We know that 2 to the third is 8. So x has to be a number between 2 and 3 and closer to 3, as you said, because, well, 7 is closer to 8 than it is to 4. Okay. Sorry. The next set of questions that we do are, well, yeah, sorry, are gonna involve the inverse property of logs and exponentials. Give me one sec. Okay. So, well, yeah. Okay. First, we got to do this. So log base 2 of x minus 4 is equal to 3. How does this turn into 2 to the third is equal to x minus 4? Huh? It's okay. It's because logs in it. Remember, logarithms are translated into exponentials. For example, when I ask you log base 2 of 8 is equal to what? What's your answer? Yeah, sure. Look up at the board. So when I ask you log base 2 of 8 is equal to what? How would you answer that? Log base 2 of 8. Yeah, it's okay. It's at the board, dear. Yeah, it's 3, but kiddo, like I'm sure that there's some awesome thing going on in your brain to like tell you it's 3, but the way you'd figure that out is by translating the log into the exponential, which is you ask 2 to the question mark is equal to 8. That's right, right? Yeah, so that's exactly what you're doing here because like question mark is the 3. So then you go 2 to the 3 question mark is equal to x minus 4 and you proceed from there. So you're translating the log into the exponential. Does that make sense? Okay, cool. So that's how we solve these. Like, and so if I ask a similar question, if I go log base 3 of x minus 5 is equal to 9, or like not so big, is equal to 2, what's your next step? It's okay. It's okay. Yes, do not forget this. Yes, but very well done. Good job. Okay. I'd rather you like think through it like you just did and tell me instead of, giving me a rush throwing answer. So it's fine. Good job. So for log base, well, the base is 10. Log of 3x is equal to 8 is the question. So here, yeah, you can put the exponent back like that, but I like what you did on your paper, which is like simplify it. Get rid of that 4, and you could do that by dividing by 4. It's like a usual equation. It's multiplying, so you can divide to undo the multiplying by 4. So that cancels. Now you have a simpler equation to deal with. Log of 3x is equal to 2, right? Yeah, now to do the same translation, you got to show the base. So that's log base 10, because log without a base is base 10, of 3x is equal to 2. And then from here, what do we say? Yep, beautiful. 10 squared equals 3x, and that's 100 equals 3x. Divide by 3. So x equals 100 over 3. Okay, good. All right, so the next one is, well, okay, so, like in the previous questions, right? It was log, like for example, in the first one, it was like log base 2 of x minus 4 is equal to 3. So, like, it was only one log on the left side. So that's why you were able to just jump to 2 to the third is equal to x minus 4. So in the question example 6, on a slightly more sophisticated question, you have two logs. So log x, I mean, it's the same base, but still it's two of them, plus log of x minus 3. So the first thing you got to do is rectify that, which is turn it into one log. Well, the way you're going to do that is, since it's a sum, we can condense it into a what? Yeah, since it's a sum, we can condense it into a product. So it turns into log of x times x minus 3 equals 1. That says log of x squared minus 3x equals 1. And then you show the base. So that's log base 10 of x squared minus 3x equals 1. And then from here, yeah, you do the usual translation. 10 to the 1 is equal to x squared minus 3x, right? Okay, so that says 10 is equal to x squared minus 3x. Bring everything to one side. So 0 is equal to x squared minus 3x minus 10. And then you know how to do your quadratic. So 0 equals factor. It's x minus 5 and x plus 2, because they minus 5 and 2 add to negative 3 and blah, blah, blah. And so that's x equals 5 and x equals negative 2. But remember extraneous solutions? There's such a thing as an extraneous solution in logs also. So I had said that your teacher, well, okay, this one you did correctly. So because like you gotta plug them in, and if you get a similar question, your answer. Because negative 2, if you plug it in, it would say log in the original, sorry. Well, and this is the equation. My bad. I went to the first one. So if you plug in negative 2, it will say right off the bat, it would say log of negative 2. No good. We said earlier you can't have log of negative numbers. That's why that's an extraneous solution. Okay, cool. Say that again. Mm-hmm. Yeah, absolutely. Like and I will always take advice like that. Okay, sorry. I always chime in. So I do want to look at like, are you sure you're good on B and sorry on both B's, 3B and 4B? Are you sure you're good on that? Sorry, say that again. Mm-mm. Oh yeah, yeah, that's the one I'm on. Example 3 at the top. Sorry, go ahead. Okay, so which one are you on? Yeah, exactly. So I feel I'm with you on that one, because like they're pretty straightforward, right? I will just have a brief mention, right? Like so if we have 2 to the 3x minus 1 equals 2 to the 9x minus 4, what's your next step? Yeah, because the bases are the same. So very similar idea, which is if you have log base 2 of 3x minus 11 equals, we can go over this page real quick. So log base 3 of 25 minus x, well, the log bases are the same. Yeah, they're both 3, my bad. The log bases are the same, so you could just ignore the log bases, just like how you ignored the bases there and just set the exponents equal. So you just take this and set it equal to that. That's the whole point that your teacher is making on this entire page. And 6B. So the evil girl that I once liked that I now hate. Her middle name is Paige. I think it's not even her real name. She made it up just so that I can never. Every time I say Paige, I will be reminded of my pain. No, really. Okay, I swear she made it up. It's not really her real name. So, example 7 is like log. No one has like 2 middle names. No, I'm kidding. Log of x minus 3 equals log of 7x minus 23, and then minus log of x plus 1. Like, we really don't need to go over this, but it's like very quickly again. So it's the same idea, which is once you get them to be in this form, you can ignore the logs and just set the insides equal. But on the right side, you have an expanded form, so you need to condense that. Since it's a minus sign in between, we know that the condensing would be done by dividing them. So 7x minus 23 over x plus 1. And then now that you've condensed and you just have one log on the left, one log on the right, and they're the same base, namely base 10, you can ignore the logs and just set the insides equal. X minus 3 equals 7x minus 23 over x plus 1, and this is a rational equation, so you write over 1 cross multiply blah blah blah. Okay, cool. Now, yeah, so the one cumbersome page is, darn it. Okay, go back to chapter. No, go back to um, like the previous chapter, the one that says example 3. So from now on, every time I say page, I mean chapter, I mean page. Okay, so you have like 5 to the x is equal to 134. And so the way you do this, right? Like, kiddo, obviously, like when we had 5 to the x is equal to 125, 125 can be written as a power of 5. So you'd be like 5 to the x is equal to 5 to the third. And then x equals 3 over. The only problem is 134 cannot be expressed as a power of 5. So what you got to do is take log base 5 of both sides. And when you do that, sorry, maybe I need to write a new step. So yeah, my bad. So you go, taking log base 5 of both sides. On the left, you have log base 5 of 5 to the x. And then equals log base 5 of 134 on the right. Obviously, on the left, log base 5 of 5 will cancel. And real quick, the reason is because, well, I'll just demonstrate. If you put the x in front, you have x log base 5 of 5. Well, log base 5 of 5 is 1. That's kind of like why it cancels. I didn't even need to mention that. I could just tell you it cancels, but you know, like I'm trying to help you remember. But yeah, they cancel. That's why we would take log base 5 of both sides in the first place, because we know it will get rid of this 5 right there, leaving us with just an x. And so then x is equal to log base 5 of 135, and the only way you can finish this is if you have a calculator. And but why do we have, oh yeah, so to type it into your calculator, you can use log base 10, and so this would turn into log, meaning log 10 of 135 over, this is not the quotient rule, it's really called the change of base formula, but just know that in order for you to type it into your calculator, like for if you have log base a of x, you could go log x over log a to get an answer from your calculator, you know, in situations like log base 5 of 135 where you are not able to do it without a calculator. Fair? Yeah. Okay, cool. Sorry. Now, on the next one, you can talk. I wanted to give you that as an example. So you have 10 to the x is equal to 8,000. So talk to me. Yes. So log base 10 of 10 to the x equals log base 10 of 800. And really, log base 10, we could have just written log 10 to the x log 800, obviously, because log without a base is base 10. But I'll be explicit and I'll show the base. All right, continue. Yeah, exactly. You get just x on the left, and then on the right, you get log of 8,000. And that you could just type into your calculator because it's already base 10. Yeah. Say your answer is x equals log base 7 of like 20. How would you type this in your calculator again? Huh? Yeah, no worries. So I wrote on the board. It's okay. So suppose you're doing some problem, and the final answer is x equals log base 7 of 20. How do you find the answer in your calculator from there? Well, you solved for x and you got log x equals log base 7 of 20. How do you get a number out of that? Oh yeah, like I think you could do that. Only because you wrote it somewhere else. You can do what's called change of base formula. This is not the quotient rule, and that change it into base 10 by doing log 20 over log 7. Okay. Okay, but this is not the quotient rule again. This is just to get an answer out. But you also just pointed out that there's another option, so you could use that other option. All right. Now, so the next one is like example 4. So you have 7 times 3 to the 2x minus 5 equals 58. I'll talk through this one. On a similar problem, add the 5 over first before you divide by 7. So you get 7 times 3 to the 2x, adding the 5 to both sides, you get 63 on the right. Then you divide by 7. Like any equation, if you have multiply, you can undo it by dividing. Okay, so you get 3 to the 2x equals 63 over 7 is 9. And at this point, you could have even used exponent rules, like solving exponentials, right? Which we said is make the bases the same. So it could be like 9 is 3 squared. And then now you could be like 2x is equal to 2, x equals 1. But the other option is to use log base 3 to cancel the 3 on the left. So you have this, so you go log base 3 of both sides. So on the right, you get log base 3 of 9. And so these cancel. You get 2x equals log base 3 of 9, which is 2. So same place, x equals 1. Fair? Yeah. Okay. All right. We're almost done, right? Okay, yeah. Yeah, good. Sorry. So 3 to the 2x minus 1 equals 7 to the x plus 1. Talk to me about this one. Exactly. There's no way to turn 7 into a power of 3, and there's no way to turn 3 into a power of 7. So, no, it's okay. Like, so what if I had 3 to the 2x minus 1 equals 9? How would you have proceeded? Well, not 9, but let's say like 10. How would you have proceeded? It's okay. Yeah, I don't even want that in your head much. Like, that's only to get an answer out. Do log base 3 of both sides, because that will cancel the 3 on the left side, right? Yeah, go ahead. Mm-hmm. Mm-hmm. Yeah, exactly. So you're not gonna it's not gonna clean up very nicely, but at least one of them will disappear. And while we're at it, like although your teacher chose the path of taking log base 3 of both sides, you could have taken log base 7 of both sides. That way the 7 on the right side will disappear, right? So it's a matter of preference. And since the 3 appears first in the equation, that's really like why we take the log base 3 of both sides. But again, technically, you could have taken the log base 7 of both sides. Make sense? It would make you'd make about the same amount of progress. Anyway, go ahead. Exactly, because this would cancel now, and you get 2x minus 1 equals. Absolutely, absolutely, you must, because look, this is why. Once we move the exponent x plus 1, again, put it in parentheses because it's more than one term. Once you put it in front, you get log base 3 of 7. Log base 3 of 7 is an ugly number if you type it into your calculator, but it's just a number, right? And so, like, that's why you want to put the x plus 1 in front, because then this is just a constant, log base 3 of 7. It's not a beautiful constant, but it's just a constant. And while we're at it, how would you figure out what log base 3 of 7 is? Yes. Again, that's the change of base formula. I'm sure, like, if you continue your log unit, like, your teacher will talk about the change of base formula. So it's not such an awful thing that I mentioned it, but I kind of like don't want to confuse you with that and the quotient rule. You're not doing the quotient rule. This is only to make sense of numbers like this, that you would change it into log 7 over log 3. And if you did that, the number you get is this ugly number 1.77. And so then the equation would turn into 2x minus 1 is equal to x plus 1 times 1.77. And then you distribute the 1.77 over here and over here. So you get 2x minus 1 is equal to 1.77x plus 1.77. And then, like, yeah, this, I mean, I don't even want to keep talking because you know how to solve this. Subtract 1.77x from both sides. And again, like, it's like, you should be very proud of, like, your intelligence and your math skills, because we did algebra, like, in 3 weeks. If I were you, I would brag about that all the time. Like if kids in your class are like, "Oh, look, I got a great grade," you're like, "Whatever, I did algebra in like 5 weeks. Keep up." 2.77. Adding the 1 to both sides. Sorry, so the 1 is gone, and then divide by 0.23 on both sides. Fair? Yeah. Okay. All right. And I mean, the next question is like much the same, but sorry. So 7 minus 4 to the power x minus 1 is equal to 18. So here, you could subtract 7 from both sides because it's not multiplying, it's added on the left. Technically, there's a plus sign in front of it, right? So that'll leave you with minus x is, minus 4 to the x minus 1 equals 18 minus 7 is 11. Then you divide by minus 1 on both sides. So that gives you 4 to the x minus 1 is equal to minus 11. Where do you go from here? Yes, beautiful, beautiful. So when you do log base 4 of 4 to the x minus 1 is equal to log base 4 of negative 11. Problem. Well, this cancels, but what is the problem? Exactly. There, you cannot put a negative number in log. Now we're done, but I want to, before we say we're done, like I want to go back to the other page that has, chapter that has the questions that you said you were comfortable with. So this is the one with example 6. Can we go back to that real quick? Yeah. So look at B. So remember, I said at the start, like your teacher made a mistake somewhere, but I didn't say where that mistake was. So it's in B, because like example 6B, because it says log 7 of 4n minus 7 is equal to log 7 of minus 3n. First issue is unless she puts absolute values around here, you can't really have negative 3n. Maybe you can. And the reason is because n may be a negative number. If n is a negative number, then negative 3 times n would be a positive number. So I'll give her that. So let's say that this was fine. Again, technically she's supposed to write absolute values, not parentheses. Okay, but then, because this is log base 7, this is log base 7, we can ignore the bases, or the logs, and just write 4n minus 7 is equal to minus 3n. Fine. So then you get, adding 3n to both sides, you get 7n minus 7 is equal to 0. Adding 7, you get 7n is equal to 7. You get n is equal to 1. This is no good, because if n is equal to 1, then 4 times 1 minus 7 is negative 3. So on the left, you'd have log base 7 of negative 3. On the right, you'd have log base 7 of negative 3. But log of a negative number doesn't make sense. So this is an extraneous solution. So I don't know if she didn't point that out, but that needs to be pointed out. So in parting, what I'm saying is, like, when you're solving equations that involve logs, make sure that your final answer, you plug back into the log and it doesn't make the log negative, as you did in an earlier problem and pointed out that it was extraneous. Fair? All right, love. Have a wonderful day. Again, work carefully, or night. Work carefully, and if you do really careful work, you should be able to get 100. You feel confident? Yeah. Okay, cool. Have a wonderful night, okay? You too. All right. Bye.